All right, so let's take a look at knowledge check 7 and see what happened on some of these problems that we had doing this particular knowledge check. So the first question tells us that approximately 46% of the population received a flu shot, and we're going to randomly select 3 people. So this is going to be a binomial situation. We know that immediately because they've given us a P and an N, which is what we need to be able to do binom, PDF, and CDF. And then to really hammer that home, it tells us that we're looking for the number of people who received the flu shot. So we're counting up the number of successes. If we wanted to go through all the pieces requirements for binomial, binary, they either got or did not receive a flu shot. Independent, if they were randomly selecting people, one is not going to influence the next in terms of whether or not they got a flu shot. We have a fixed number of trials because we're looking at those 3 people, and that probability of success, since we're randomly selecting people, is always going to be that 46%. So definitely a binomial. And I'm asking you to fill out this entire table, which means that we're finding the probability of none of the people having a flu shot, 1, 2, and 3 of the people having a flu shot, which is exactly the setup for binom PDF because we want one particular outcome. So all you had to do for this particular question was come in, do binom PDF for our N of 3, our P of 0.46, and then for each of these different outcomes. So the first one would be a 0, and then just round those appropriately. And then you can just bring that back and change it to a 1. Another thing you can do, I don't think I had any videos of this semester, but if you take binom PDF and you just feed it the N and the P, the 3 and the 0.46, it will actually give you all of the different outcomes, everything here in order. So it will give you 0, 1, you can scroll 2, and 3, so from none to all. So you could actually just do that and it would have given you all the values without you having to re-enter binom PDF 4 times. So that was question 1. Question 2 looks like, okay, 2 labels, 2 containers, A and B with red and blue. Each is shaken vigorously. After choosing one of the containers, you'll reach in without looking and draw out a marble. And in this case, the proportion of blues is the same for both. So we're equally likely because if blue is the success, we're looking at 40 out of 100 or 4 out of 10, and those are the same proportions. Now, the second question says we have to pull 2 blue marbles to win the $50. So now we have to think about those different probabilities, right? So we're doing this without replacement. So let me pull this up. This is actually a question from part 4 from probability, but we need them to be both blue. So that means we have a blue marble and then another blue marble. And so we have one situation where we're looking at, 4 of 10. And if I take out that blue marble, I now have a 3 of 9. And the other situation was the same thing, except for it was 4 out of 100 and then 39 out of 99, right? We're changing it instead by that. So what you're going to find is that this probability is greater than this probability. So it is more likely in the second situation to pull 2 blue marbles. And that's how you could have actually calculated it instead of just trying to use intuition. Because one thing you'll find out about a probability is that a lot of the time our intuition is really wrong. Question 4 is probably where I saw the most mistakes. We did pretty well in the first 3. So we're looking at a binomial and we want more than or equal to 5. Okay, so let me just, bring this back. No, that's not what I want, pressing every button, but more than or equal to 5. So greater than or equal to 5 is the outcome we're interested in. So how many did this go up to? What was our N? N of 6 only, okay? So we're gonna stop there. And more than or equal to 5 is here. So one possibility would be just to do PDF for both 5 and 6 and add them together. Another possibility would be to use CDF, and if we use CDF, we need to do a 1 minus, and that's CDF up until 4, because that's the other side of this, right? It ends at 4. So those were the two possibilities. If you only chose one of them, I gave you 1 point back. So if you had just one of these two things checked. But if you checked something wrong, I did not give you any credit. So those are the two things you should have selected there. Question 5. We did pretty good on this. Our problem here in this panel was basically that he's thinking the complement of winning all three is the other person winning all three. When in reality, we're again thinking kind of about that binomial, the same thing we were just drawing out. So if we're talking about this one, the number of states the person won could be 0, 1, 2, or 3. So when he talks about the probability of winning all the states, he's only here. And the complement is winning 0, 1, or 2. But if the person wins 2, then his candidate still loses. So that was the biggest flaw in the reasoning. Now, some people did a really good job of explaining that in the next question, but that was not what I asked. The next question says that the 3 states are independent. And then I asked whether or not you thought this was a safe assumption. And I honestly didn't have a right answer here. I just wanted to see good reasoning. So some people told me that no, they're not independent. Certain regions of the US tend to vote similarly, which is a valid reason to say that there's some dependence. Some people told me that if the results are coming in at different times, then it's possible that one outcome in one state might influence how votes go in another state. So they told me it was dependent. And some people told me that states didn't influence each other. And I, as much as I preferred the other two answers, I still gave full credit for that because you defined what you thought what independence was, and you gave a decent reasoning for it. And then the correct probability for the dad in the comic winning the primary, well, in order for him to win, that would be the opponent winning 0 to 1 of those states. So suggested binomial, n of 3, probability of success, he said, was 60, and this is a perfect setup for binom CDF of 3.6 and 1, because if they win 0 or 1 states, his candidate will win. You could also set this up based on his candidate, right? You could have set it up based on his candidate has a 40% chance of winning each state, and then he has to win 2 or 3, but that actually makes it a little more complicated because you need to do a 1 minus or add up the 2 and 3 like the previous question. So that's it. And then question 8 is a question I've used before on a test and students got wrong. This is the idea that just because we use a lot in part 4 this classical approach to probability, a lot of students want this to be the case. Since there's 4 outcomes, there's a 1 in 4 chance of each. But if you've ever played Pass the Pigs, which is a game where you basically roll pigs, not everything is equally likely. It is much more likely for the pigs, or in this case, the little dog, to land on its side than it is for it to land standing up or on its back. So we can only use classic probabilities if we know everything's equally likely, like flipping a coin or rolling a die. And if we don't know, then the only thing we can do is basically do an experiment where we toss the thing a bunch of times and see what happens. The last answer choice here, or the next one, has simulate, which sounds really good, but then it still says equally likely outcomes, which is the same thing as the first one. So your answer choice that should have been correct was the second answer choice.